Alrighty, let's go ahead and start with a couple of examples here. That's what the whole right column's for, is writing a couple of examples of each one. So for the first one, how about y equals x squared, and then since we're going up, what should I write? Plus 4. Beautiful. What about another one I could shift up? Y equals, sure, x plus 3. Beautiful. Alright, what am I going down? Y, that means minus, so what parent function do we want to use? We can do that, sure, linear. Y equals x minus 17. Love it. How about use the square root? So y equals square root minus, use base 5. If you want to change it to your own equations, that's cool. We're just writing examples, everything we've learned in the past couple of days. Alright, 8 units left. So this one we gotta use parentheses. So maybe if I did like the quadratic, what am I gonna write on the inside? X plus 2, awesome. What if I did cube root? What should I write on the inside? Yeah, x plus 20. Oh, shoot the star. I like it. Okay. 8 units to the right. Same idea, right? Let's use, how about cubic this time? Some other than Alicia. X what? Minus 3. Like another parent function that we use? We haven't used it yet. Yeah. Y equals absolute value. Going to the right, so I need a minus 1. Perfect. Excellent. Although that kind of looks like 11. Oh well. You know it's fine. We don't. Yeah. Okay, vertical compression and stretching. So first one's compression. So y equals, and maybe 1/2 x squared? No, y equals, give me a fraction, third grade. We'll just do x, so third x. Ma'am.
So you're doing the vertical compression?
Yes, ma'am. We're doing vertical compression as a fraction. We're doing horizontal compression. Yes. Right, 0 to 1. So that's one fraction. Okay, vertical stretch. So it's something bigger than 1. Y equals 3x. Y equals, give me another one. Number, go. 300. Great. Awesome movie. Yeah. Yeah. This is Sparta. Of course you can do that. Y equals 300. What parent function do I use? Oh, beautiful. X squared. Love it. Love it. L-O-V-E-it. All right. Now we're going compression toward the y-axis. So it's getting like, if you want to think about it, it's getting narrower, but we're doing it for the y's, or we're doing it for the x's as opposed to the y's. So still going 0 to 1 here. So y equals, now this time we're on the inside, so maybe 1/2 x and then squared. What's another one? Y equals, I know, square root of 1. Give me another fraction. 3/4. 3/4 x. All right, switches away from the y-axis. This is another way of saying like it gets fatter, it gets squattier, it's stretching away from the y-axis, kind of pulling it apart from the y-axis. We're going to think about it that way. So y equals a number bigger than 1. 2. What parent function are we doing? Cubic? Y equals, let's do cube root here, and 27. Just because we can. Let's see my red and white thing going on, or red, white, blue thing going on. You're welcome. Cool. All right, what else you got? Reflection across the y-axis. Y equals negative go on the outside or inside? Outside. So I'm going to put that, and then you pick your favorite. I know it's hard, but pick your favorite parent function. No, that's not enough. You have to put one of them. Whatever your heart desires. Is it absolute value? Is it x squared? Not this. I'm going to go negative x squared. That's just my favorite, personal favorite. All right? No number. Y equals, I'm going to stick with the exponent theme here, going cube. You can put a number in front if you want, but here we're just talking about the reflecting across the y-axis. Oh, sorry, that should be x. Not bad. Not bad. Sorry. Okay, what else we got? Something across the y-axis. So now we're doing on the inside of the parentheses. Sorry for that. So I'm going to use the same one, except this time I'm going negative x on the inside and then squaring. Same thing. Y equals negative x. Does that help going through all the different transformations? No, not at all? Okay. Let's move on. We're moving to monster. Quite a scary monster. Alright, let's plot let's name all of our ordered pairs. So right here, that's negative 4 to 0. Zoom in a little bit, even more. Negative 4 to 0. What's my next point? Negative 1, negative 3. What else? 0, 1. 0. 2, 1, and 3, 0. Okay, so when we're saying move the monster, we're just going to be moving this shape all around. If you think it looks like a monster, that's cool. Whatever. If you don't think it looks like a monster, that's okay too. Okay, our domain. What is my smallest x value? Negative 4. And what's my largest x value? Okay. My range going bottom to top, smallest to biggest, least to greatest, negatives to positives. Negative 3, 2, 1. Why am I using brackets? I don't know. Alright, so that's our original. That's what we're going to be moving all around. Okay. If it gives us our original, how does the negative change everything? Negative on the outside. How does it change it? Put it over the x-axis. So does my first point change at all? No. My next point definitely changes from, I'm going to go ahead and plot that one. And then this one changes from, instead of being a negative 1, negative 3, now it's at negative 1, positive 3. Coming at 0, 1. Now it's at 0, negative 1. 1, did my 1, 0, does that point change at all? No. Just reflecting it. That's all we're doing here. All right, we already talked about, we sketched the graph. Let's do domain and range real quick. Did my domain change at all? No, so my domain is still from -4 to +3. My range, do we have a spot at the bottom for that? Okay, sorry. My range flip-flopped, right? So what is it now? Looks like it's from -1 to +3. What was our domain? Cool. Type of transformation, we can say reflection. And effects on domain and range, what do we want to say? Change the y's. Change y values. Change y's, or however you can say that. Okay, for number 2, what changed here? What's happening? Negative's on the inside, so what is that going to do? Yeah, so it's another reflection. This time it's over the y-axis. Probably should say on our previous one that it was over the x-axis. Okay. So now, instead of being at -4, comma 0, it's now going to be at +4. Instead of being at -1, -3, it's now going to be at, excuse me, and -3. Now it's going to be at 1, -3. Does my point on my y-axis change at all? No. And then all my other points. Did our domain change this time? Sure did. Now it's going from -3 to +4. My range? Stay the same? Stay the same from our original, right? Not from the one that we just did here in blue, but from our original. So it's still -3 to 1. The effects on the domain and range, it changed the x values, yeah, it changed the domain. Right, we're finding the domain range of the new one every single time. We already did our old one. On to the back. Wow. Okay, what's the plus do on the outside? Up, down, left, right, what? Yeah, so it's a shift, we'll say vertically. Vertically 1 L or 2? Shift vertically up 2. So is that changing our domain at all? So my domain is still going to be from, what is that, -4 to 3 still? And what happens in my range? Everything goes up too, right? So here's our first point. There's our next one. So we already said our range went up 2, so I could say from, I'm just going to add 2 to both of the y values. So -1 to that 3 now. Our effect was just on the range, we said that. So y values, I'm just going to do some shorthand here, up to. For the sake of not beating a dead horse, do we know what -2 does for number 4? Yeah, it goes down 2. So I'm just going to do down 2 right here. Are we all okay skipping this? Because we all know that it goes down 2. Anybody opposed? Okay. Sorry. Oh, this was just taking the original function. We don't need to worry about that. Because the original function's on the back. Okay, for the next 2, what type of shifts do we have going on there? Horizontal or vertical? Yeah, these are both horizontal. So it's a horizontal shift. And what's that plus 2 do on the inside? That. What about the -2 on this number 6? Yeah, it goes right to. Okay, you pick 5 or 6. You got a minute and a half. Okay, we got either graph there. Our domain, the x values are going to either go to the left 2 for this one or to the right 2 on that one. So depending on what you did there, if you did, who's our fivers? Anybody do number 5? Okay, what's our smallest x value? -6. Cool. Our biggest one is +1. And did our range change at all? No, so -3 to 1 still. The effects is that we moved all of our x values that way too. Okay, my sixers. What's my new domain? -2 to 5. Excellent. Did my range change at all? No, it did not. And this time it moved all my x values to the right. If you want to say increase x values, decrease x values, that's cool. We'll move on. I'm going to write this down. We got 4 more. Almost there. Okay, number 7 and 8. What type of transformation are we talking about here? What's that number on the outside tell us what we're going to do? It is a vertical stretch. Vertical stretch when there's a big number on the outside. If it's a small number on the outside, what's happening there for number 8? It's a compression. So it's a vertical. Oh, sorry, that should go in transformation, shouldn't it? Vertical compression. Okay, so do my x values change at all on either of these? Do we say anything about horizontal x's, anything like that? No. So all my x's are going to stay the same from -4 to +3 for both of them. What about my range though? What happens there? Increases by 2 or multiply everything by 2, right? So here the value stays the same, but for this one, instead of being at -3, now it's going to be at fill in the blank -6, right? My next point, instead of being at 1, is going to be at 2. These two right here don't change at all, not on the other one. That middle. So now my range stretching, instead of being at -3 to 1, -6 to 2, which makes sense because we multiply all our y values times 2, which is our range effect. So y values times 2. So number 8, compression. What's going to happen to our picture? What's it going to look like? It's going to get like squishier. It's going to get, this value doesn't change at all. Instead of being at -3, now it's at -1.5. Now it's just not as, and I didn't be able to see that on there. Not as long, tall, however you want to say that. Now where we divided our range by 2, to multiply. So now it's going to go from -1.5 to, what's my finishing, or my highest y value? 25, or 1/2. So y values, we say divided by 2. Once again, this table is just to write out the original function order pairs if we want. We kind of already did that, so no need to be redundant. All right, last two, final push. Here we go. What do the numbers on the inside tell us to do? Yeah, so if it's bigger than 2 or bigger than 1, that's the compression. And if it's bigger than, sorry, if it's smaller than 1, between 0 and 1, that's our stretch, so the horizontal stretch. And remember, this is like doing the opposite. So horizontal stretch can be by a factor of 2, because we're stretching everything by a factor of 2, or the reciprocal 1/2. For this one, horizontal compression by reciprocal 1/2. So it's opposite than what we think. So on this picture, instead of being at, let's see, -4, now it's going to be at -2. Instead of being at -1, now it's at -0.5. My 0 one didn't change at all, and everything else. You want to think about it that we're fitting more graph in less x values. You think about it that way. Our domain for my red picture here is from -2 to 1.5. Our range still stayed the same. So our effect was we divided all of our x's by 2. $410, last one. Woohoo! Multiply all of our x's times 2. So instead of being at -4, it should be -8. So being at -1, it's at -2. Stays there.
Let's say Y's or X's.
Alright, x. Boom. Our domain now is from -8 to 6, appears to be. Our range didn't change at all. And we multiplied all of our x's by 2. It appears that whoever made these notes should have flip-flopped these